this video, we're going to explore the FMECA interface. It must be said there are at least two methods or two ways of performing an FMECA with ReliantSoft XFMEA. The first one is the traditional one, and to enable that, we are going to go into application setup. When we launch our project, go into application setup, and we make sure that under settings, we make sure that this enable MIL 1629A criticality is activated. Once we've done that, we're able to see the icons that it refers to the MIL 1629 FMECA analysis. So we go back to our system that we used before, and we want to perform an FMECA analysis on this system. We notice that we have some names of manufacturer like Dunlop and Continental, but I just want to make sure that we're clear on that. Whatever numbers we produce has got nothing to do with the manufacturer. This is just pure an exercise. And we're under the Home tab, and now we have an icon, a specific icon for FMECA analysis. So we click on that, and we select whatever items we want to consider in our FMECA. And that opens up a new window for MIL 1629 criticality analysis. We have previously inserted this information concerning to the mode ratio, so we're saying that basically 76% of failure are attributed to this type of failure, and 24% are attributed to this type of failure, for a total of 100%. And for the first one, we have, say, a 75% probability of loss, and for the second one, we'll have 100% probability of loss. So wherever we have a default actual loss, it simply implies 1 or 100%. And we have a reliability model inserted. We were actually trying to pick up models from other parts of the FMEA, but we noticed something that is worth drawing your attention to that. So these models, we can see from these strange icons, are global models. And if we click on here, in fact, it gives us this little error, but that doesn't frighten us. We can see that these models are global, okay? And most likely when we are working and creating new models in different parts of Weibull and so on, and we want to reuse in other software, they are local. So we have to make sure if we want to use them in this FMECA, we have to make them local. But we have to pay attention to the fact that this is a one-way street. We cannot go back and convert this global model into local again. So that's something to pay attention. Okay, so we inserted these models. Some of them are exponential, some of them are Weibull, could be log normal, and so on. And now all is left is basically to calculate. And just before we do that, we've also manually mapped the severity class that relates to the standard 1629. So we click on calculate, and that populates everything that wasn't populated before. It estimates the failure rate at 3 years for all of them, and obviously for the first one is simply an exponential failure rate, and multiplied by the number of hours accumulated in 3 years. For the others instead, because you have a variable failure rate, is obviously estimated at 3 years precisely. So once we've estimated the failure rate, then we can use that to calculate the mode criticality, and it's nothing but the product of the failure rate times the probability of loss times the mode ratio. And once we've done the mode criticality, we add the two together and we get the item criticality. So this is how we can construct an FMECA, and ReliantSoft XFMEA will help us to fit together all the different parts we need. And once we've done that, we can produce the report, and we have Excel type spreadsheet that we can produce about our analysis being compiled, and also the criticality matrix. Okay, so this is one method of creating an FMECA analysis. In the next video, we'll be looking at a second type of interface we can use to construct an FMECA.